Okay, today we're going to talk about unit rate and how we can find unit rate from a graph. So first let's review the idea of rate. A rate is a ratio with a different unit in the numerator and the denominator. So for example, if I had 30 miles in 2 hours, so I could represent as 30 miles in 2 hours. Now the unit in the numerator is miles and the unit in the denominator is hours. Miles is a measurement of distance, whereas hours is a measurement of time. Because these two units are different, they measure different quantities, they are considered different units. So this right here is considered a rate because it has two different types of units. Now for instance, if I used two units that measured the same thing, like minutes to hours, like let's say it's 30 minutes, or really it's 60 minutes in an hour, right? So 60 minutes is to 1 hour. This is not considered a rate because minutes and hours measure the same thing. They both measure time. Okay, even though the units are not identical, they are measuring the same quantity, which is time. So this is not a rate. Okay, so 20 gallons per 100 miles is also a rate because gallons is a measurement of volume, where miles is a measurement of distance. Dollars, $100 per pair of shoes. So dollars is one measurement and shoes is another. Those are two different types of units. A unit rate is a rate that has a unit of 1 in the denominator. So instead of having, in the first rate we had up here, we had 30 miles per 2 hours. That is a rate, but it's not a unit rate, right? An example of a unit rate would be 60 miles in 1 hour. That's a unit rate because I have 1 in the denominator, okay? This is often abbreviated as 60 mph. So you can see this unit, miles per hour, is a unit that we use frequently when we talk about speed. $3.49 per gallon is also per 1 gallon. 32 miles per gallon. So 32 miles per gallon is a way to measure the efficiency of a car. So the nice thing about unit rates is that we can use them in order to compare two different products, for instance. So let's say I have car number 1, and car number 1 gets 32 miles per gallon, per 1 gallon, or 32 mpgs. Okay, and car 2 gets 35 mpgs. Which one is a more efficient car? Okay, which car would you rather buy? If everything else is equal, which car would you rather buy? And the answer is you want the one that gets more miles per gallon, right? So it's better if car number 2 gets 35 miles per gallon, because every gallon of gasoline that I put into it, it drives 35 miles, as opposed to car 1, which only drives 32 miles for every gallon that I put into it. Okay, so the higher the MPG is, the better the car is. All right, that's different than like the price of gasoline, where the lower the price of gasoline, or the lower the price per gallon, the better it is for you as a consumer. Okay, so if I have to find the unit rate, and I'm given a graph, there's a couple of different ways I can do it. First of all, this one's fairly easy because what I'm looking for is the unit. Okay, the rate is always the dependent variable over the independent. Okay, so this is always the y over the x. So we're looking at some sort of ratio of y to x. Okay, so it's easy to do, and meanwhile, so this is the rate. If I want to make it a unit rate, then what I want to do is I want to figure out how many y's for 1x. Okay, so here we've been given the units of time and distance. Okay, so we want to have kilometers per 1 hour. So I am wondering how many kilometers, so maybe you can make up a situation here. This is the distance that like a kangaroo hops. Okay, so it would go kilometer per hour. So how many kilometers would it hop in 1 hour? So here, this is 1 hour versus 2 kilometers here. Okay, so we sort of have our answer here. So it's 2 kilometers per 1 hour. I can also write that as 2 kilometers per hour. And that is our unit rate. Okay, or you can write it in terms of a fraction like this. Okay, this next one's a little bit more difficult. So let's say, well, I'm not even given let's make up a unit for our x. So if I have distance, let's make this minutes. Okay, so we can see, oh, these little squigglies mean that it doesn't start, the space between the first, from the origin here to the first unit is not going to be incremented the same way. So between the second and the third unit, that's 1 minute, right? Between 9 and 10, that's 1 minute. But between 0 and 9, this right here is a span of 9 minutes. So it means that the graph doesn't increase in the same manner. Okay, we do this when we want to kind of zoom in on a graph. You might have learned this in statistics in 7th grade. So we make these little squiggly lines if we don't want to start, if we don't want to write, you know, like if I go 1, 2, 3, 4, 5, 6, 7, 8, 9. Basically, if I want to squish this distance down so that I start, so that 9 is the first one, and that 10, and then it goes by ones after you've made your first tick mark. Okay, so we can use those little scrunch marks to mean that, these little things like that. Okay, so if I go, so this first point is 9 minutes and 28 miles. Now, I am trying to figure out the unit rate, all right? So what I want is I can set up a proportion here. So it's I want to do miles per minute, right? Because I want to do the x, or I want to do the y over the x. So let's see, I have 28 miles in 9 minutes. Now, to find the unit rate, I'm wondering how many miles there are for 1 minute, because the unit rate has a 1 in the denominator. So if I set up this proportion, if I go 28 miles in 9 minutes, then how many miles would I go in 1 minute? All right, so I can use the cross products here. So 28 times 1 is 28, and then 9 times x. So 28 is equal to 9x, divide each side by 9, divide each side by 9. X is equal to 28 divided by 9. So 9 goes into 28 3 times with 1/9 as a remainder. Okay, so that you're solving for the miles. So if you go 28 miles in 9 minutes, that means that you go 3 1/9 miles per 1 minute. And that is my unit rate. Okay, it's a rate because the numerator is measuring miles and the denominator is measuring minutes. Those are two different types of units. It's a unit rate because I have 1 in the denominator. Okay, for the next one, so let's see, how fast is the car traveling? So if it's miles, whoops, I don't want miles on the numerator and the denominator. So let's put, if I want to do miles per hour, okay, so the miles depend on the amount of hours. So let's see. Let's locate the first point where it meets at an integer value. You don't want to choose this point right here because even though it's 1 for hours, it's really difficult to see where this meets. Like this, the x coordinate here is 1, but it's very difficult to see what the y coordinate is because it's not an integer value. Whereas this one is 5 hours and 3 miles. I know what this coordinate means right there. I know what that coordinate is. Okay, 5 miles and 3 hours. So remember, I want to make it y over x. So that's miles per hour. Okay, and if I know that it goes 3 miles in 5 hours, okay, this must not be a car. This must be like, I don't know, some sort of animal. maybe it's like an insect. I guess 3 miles is a little far for an insect to go, but maybe it's just something slower. Maybe it's something like a piece of construction equipment or something. If it goes 3 miles in 5 hours. So we're trying to figure out how many miles this goes in 1 hour. Okay, so we do 3 times 1 is 3, and then 5 times x is 5x. And divide by 5. X is equal to 3/5. So what we are left with is that this whatever thing is traveling at this rate it's traveling at 3/5 of a mile per 1 hour. Okay, so every hour it goes another 3/5 of a mile. Okay, so that's our unit rate. So sometimes unit rates are the numerator is a fraction, and that's perfectly fine. Okay. All right, so let's just, and these have the squiggly lines here. Oh, these actually aren't given any values here. So let's say this increases, this starts at 20 and it goes up by 1 here. So after it has a squiggly line, so that I know that this is a greater space between, then this would have to be 19, 24, and so on. And this also has the squiggly lines here, so let's say this is $10, and now it goes up by 1s every time, and so on. Let's pick a value here. So this is 21 pounds for $12. Okay, so we want to do dollars per pound. All right, so we have 12 over 21. If it's $12 over 21 pounds, okay, $12. I'm wondering how many dollars it's going to be for X pounds. Oh, sorry, for 1 pound. Okay, so 12 times 1 is 12, and that's 21 times X is that. So divide by 21. X is equal to, 21. Okay, so 12 divided by 21, and actually that can be reduced by 3. So divide the numerator by 3, which would get you 4, and the denominator by 3, which would get you 7. Okay, so that means that it's 4/7 of a dollar for 1 pound. Now, I sort of made this up, so it's coming out as a little bit strange. 4/7 of a dollar per pound. Now, you would never really see this because what's 4/7 of a dollar? We can sort of estimate that actually, right? 4/7 of a dollar. If 1 cent is, or if there's 100 cents in a dollar, in $1, okay, you are wondering how many cents are in 4/7 of a dollar. All right, so if you actually want to go through with this, it's like 100 times 4/7, which would be 400 divided by 7. So, okay, that ends up being about 57. I just used a calculator to sort of estimate. It was 57.14, and I rounded to 57. So, 4/7 of a dollar is about 57 cents. And that makes sense because 4/7, 4 is a little bit bigger than, it's a little bit more than half of 7. And 57 cents is a little bit more than half of a dollar. Okay, so if this thing, whatever is costing this, if it's 21 pounds for $12, it's about 57 cents, or $0.57, or $0.57 for 1 pound. Okay, and that's the last slide of that. So, sort of the moral of the story is that these unit rates don't have to be. Sometimes you have to estimate, like I did in this case, mostly because I made up these numbers. But that's okay because that's how people make these. That's how people find the unit prices. If you have like a box of pasta noodles and you want to compare it to another box of pasta noodles, sometimes people will compare the price per pound or price per ounce, and it's sort of a rounded figure. You can see this oftentimes in grocery stores. But, in terms of dollars, the fraction doesn't make sense, so I estimated it to cents, and then I could use it to compare that way. So sometimes the unit rate is not a whole number, it's a fraction, and the way to find the unit rate is to pick a number that's a good number for the graph. So it meets at x and y coordinates that are integer values, and then set up a proportion to find the unit rate.